Hi everybody. My name is Ajay Singh, and we will be talking about recursion in general, as well as we will be showing. I will be showing its application using Java. So, what is a recursion? So, recursion is a kind of a repetition. So, whenever a method calls itself to achieve something, it is known as a recursive call, and the whole methodology or the technique is known as recursion. So I'll take an example of factorial. So if we have some understanding of the factorial method in mathematics, so this is essentially factorial. So factorial function is a kind of a function where if I give a number factorial 5, it will be calculated as 5 into 4 into 3 into 2 into 1, right? And as per definition, factorial 1 is equal to 1, or we can say also factorial 0 is also 1. So factorial 1 and 0 both are equal to 1. So essentially, using this as an example, I'll explain you recursion. So in this case, if I talk about a recursive method, so the factorial method here is recursive. If you look at the structure, we have defined if factorial 0 is present, it means n is equal to 0. It will return us the 1, which is essentially the definition over here. Else it is n into factorial n minus 1, which is kind of getting to this thing, right? So if the number is 0, it is 1. If the number is not 0, it can be defined as n multiplied by the factorial of one number less than n, right? So I'll showcase you by debugging it. If I try to calculate number 5, factorial 5, how it will calculate. Allow me to run this in debug mode and we'll see what happens. I haven't put any breakpoint. Okay, I have put one breakpoint. I'm running it in debug mode. So as we can see, it's in debug mode now. So if I press on say F5, let me try again. Okay, something has happened. Hmm. Okay, so essentially I'm trying to print factorial 5. So as it has called factorial 5, so it has called the factorial method here with n is equals to 5, as we can see here, right? Um, if n is equals to 0, it should return 1. If n is not equal to 0, as it is 5 now, it will go to the else condition and it will try to find 4. But it doesn't have the answer for 4 as well. It will again call this method with n equal to 4, and it will recheck the conditions. It will continue until n is equal to 0. Now n has become equal to 0, as we can see now. It will go to the if true condition, it will return n, and then we can say it has the answer for n. Now it can calculate based upon the basic condition, which was n equal to 0. It can now build up the whole thing by increasing the number. Right now n has become 2, and then 3, and then 4, and then 5 as well. right? So now with 5 it will return the result for factorial 5 and it will print, which is now 120. So with this we have understood how we can use recursion to calculate the complex things as well. So it, code wise it's very simple, and we can calculate the factorials for even very big numbers as well. For example, if I take factorial to 20, as factorial grows very fast, so if I run this, I can see that the number is e raised to power 18. If I increase this further, say to 30, let's see whether it can calculate or not. So it's like e raised to power 32, which is 10 raised to power 32. Okay, so using the recursion, we can solve many other problems as well. In my next video, I would be sharing some more examples how we can use recursion to calculate more complex things as well. Thank you very much.